We're going to do some more constructions now, this time based off of parallel lines and quadrilaterals. The first construction we're going to do is basically the parallel postulate. We have a line and a point not on the line. We're going to construct a line that's parallel to our given line that goes through our point. So the first thing is to draw a straight line that goes through the point and intersects our given line. The reason for that is that's going to serve as our transversal, and all we need to do is construct a corresponding angle to be congruent to this angle down here. Or we could do this obtuse angle. It doesn't matter which angle we do, just pick one and construct the corresponding angle. So to construct a congruent angle, we first put the tip on the intersection, stretch out our compass, and draw a arc, and move up to the other point that we're going to go through. Make a similar arc. Then bringing your compass back down, we need to measure the distance from where the arc intersects each line. Once you have that distance, that length measured out, mark the same length on the corresponding arc. The intersection, that X, will be the second point for our line to go through. And then you have parallel lines. Next, we will construct a rectangle given side lengths. So the first thing we're going to do is start with a straight line. Then, since rectangles are all the angles are perpendicular, they're all 90-degree angles, we're going to construct a 90-degree angle. So start by measuring out an equal distance. And make sure you mark the point that you're starting with. Then from each of those points, mark out a new distance. Go a little bit further than that. And do both above and below. Go to the other side, the other point, do the same. And if you draw a straight line connecting you have perpendicular lines. So next we can use our compass to measure out the lengths. So if that's length A, we can measure that out. So we have length A now from here up to here. We also need the length of B, so let's go ahead and measure B. And then we'll mark that same distance on the first line we had. Now that's a length of B. Now, using that as another vertex, we are going to need to make another perpendicular here. And from there, draw the arcs so we can construct our perpendicular line. Measure out length of A one more time. And we don't need to draw another perpendicular because we already have, this is length A and this is length A. So if we just draw the final side that goes through there, we get our rectangle. Our last construction we're going to look at is how to divide a line segment into 3 or however many congruent segments we want. So for this, the first thing you're going to do is draw a ray that starts at one of the endpoints of our segment. Then along that ray we just drew, we're going to mark out a certain distance as many times as we are supposed to divide the segment. So we're going to divide it into 3, so I'm going to mark out 3 segments of this length. Then just draw a straight line from the other endpoint to our final marked off length. Then if we construct parallel lines to this one we just drew, construct one here and here, the segments along our original side that we're trying to divide, those segments will be congruent since the segments on the ray that we drew were congruent and the lines were parallel. So we need parallel to this line over here that goes through this point. So that's just like our first construction we did. Put it on the vertex, get a set length, draw an arc, do the same thing from where the other vertex will be, draw an arc. We can actually do that for our other line at the same time since we will be doing it again. Next we need to measure the length of that arc we just drew. Mark that same length. And if we draw our segments from the 2 points that we have, those segments are all parallel and they are spaced evenly apart on one side, so that means they are spaced evenly apart on the other side.